Hello and welcome to the differentiation revision session. So we're going to jump straight in with the question. Find the gradient of the curve y equals 3x cubed minus 5x squared minus 10 when x equals 3. So to answer this question, the first thing we're going to do is we're going to find the gradient function. This we know as dy by dx when we differentiate this equation with respect to x. Now looking at the first term, if we differentiate this first term, we multiply by the power, so it becomes 9x, and then we subtract 1 from the power to give us 9x squared. Second term, this will become minus 10x, the 2 becomes just a 1, which we won't write, and the constant term, minus 10, just vanishes as it has no power of x. So this is our gradient function. I can use this to find the gradient when x is 3. So when x equals 3, the gradient dy by dx is 9 times by 3 squared minus 10 times by 3, which is 9 times 9 or 81 minus 30. So the gradient is 51 when x is 3. Let's have a look at another question now. This time the question is the other way round. In the previous question we were asked to find the gradient at a given point. Here we want to find the points on this curve when we're given the gradient. Our approach is going to be very similar, and we're going to start off by finding the gradient function for this curve. Gradient function again, dy by dx. Really important to use the correct notation in use of maths. So this time when we differentiate it, this is going to become 6x minus 5, and again the constant term will disappear. So this is my gradient function. I want to find when this is equal to 7, so to do that I'm going to make this into an occasion. Find when 6x minus 5 equals 7. So this is obviously going to be when 6x equals 12, or in other words, x must be 2. So I found the x coordinate now, but it asked me for the point, so I want to find the coordinate. To find the coordinate, if I know the x value, I can substitute this into the original equation to find the y value. So y equals 3x squared minus 5x plus 3. So if x is 2, y must be 3 times 2 squared minus 5 times by 2 plus 3, which is 3 times 4 is 12 minus 10 plus 3, which I make to be 5. So y is 5 when x is 2, so the point has coordinates 2, 5. So I found the gradient function, I made this equal to the gradient I was given, I solved for x, and then used this value of x to work out the value of y to give me the coordinate. Let's now have a look at a increasing or decreasing function question. So in this case we're told that v is the volume of a tank after t seconds, and v is given by the equation v equals t cubed minus 3t squared plus 5t. We're asked, is the volume of the tank increasing or decreasing after 3 seconds? To answer this, we need to look at the rate of change of the volume. This is the first differential dv by dt. This is the rate of change of volume with respect to time. So let's differentiate this equation now. So again, same rules as before, bring down the power. We get 3t squared minus 6t plus 5. Now I'm only interested in the case after 3 seconds. So when t equals 3, what happens to the rate of change? Well, the rate of change is 3 times 3 squared, 3t squared, minus 6 times by 3 plus 5, which is going to be 3 times 9, 27, minus 18 plus 5, which is 9 plus 5 is 14, which is a positive number. So we know that dv by dt is greater than 0, the rate of change is greater than 0, so the volume is increasing. So when the gradient is positive, it means that the original thing is increasing, and if the gradient had been negative, then it would have been decreasing. Let's have a look then, extend this a little bit further into questions involving the second derivative. So we're asked to find and classify the stationary points of y equals x cubed plus 3x squared minus 9x minus 21. Now, can we remember when stationary points occur? Stationary points occur when dy by dx equals 0. So when the gradient is 0, that's why we call them stationary points. So we need to find dy by dx. The gradient function in this case is 3x squared plus 6x minus 9. Again, the constant term goes. We've just said it's a stationary point, so that means that this 3x squared plus 6x minus 9 must be equal to 0. And if I try and solve that using any method that I choose, I should get two solutions, x equals minus 3 or x equals 1. So there are two possible solutions, so we're going to get two possible stationary points. Now, I should note, it has asked me to find the stationary points. At the moment, these are just the x values, so I need to find the y values. So when x equals minus 3, the y value, well, I can find that by substituting this number back into the original equation. If I put minus 3 in here and work it out, I should get a value of 6. And when x equals 1, if I put 1 into this equation, that's going to be 1, plus 3 is 4, minus 9 is minus 5, minus 21, y will be minus 26. So just writing these as coordinates, this is minus 3, 6, and this one is 1, minus 26. So, I've now found both the stationary points, but I've been asked to classify them, so to find out if they're a maximum or a minimum. I don't yet have the right information to do that. I can't use the y values, that won't tell me if it's a maximum or a minimum, and I can't use the first derivative, that won't tell me if it's a maximum or a minimum. Rather, I have to use the second derivative, d2y by dx squared. To find that, I take the first derivative and I differentiate that again. So 3x squared becomes 6x, and 6x just becomes 6, and the minus 9 disappears completely. So once I've found the second derivative, I need to evaluate this for the two x values I've already worked out. So when x is minus 3, d2y by dx squared is 6 times minus 3 plus 6, which is 6 times minus 3 is minus 18, plus 6 is minus 12. This is less than 0, so my second derivative is less than 0. Therefore, this point, minus 3, 6, is a maximum. Remember, if the second derivative is less than 0, it is a maximum. What about my other case then? When x is 1, d2y by dx squared, that is 6 times 1 plus 6, substituting into this equation I've got, which gives me 12. which is now a positive number. Therefore, this point is a minimum. Remember, if the second derivative is greater than 0, we get a minimum. Finally then, there's one other situation we need to look at. So we're dealing with the same curve still, but this time I want to find when the second derivative is 0 and comment on its significance. So from the previous slide, the second derivative we worked out was 6x plus 6. So to find when this is equal to 0, I just need to work out 6x plus 6 equals 0. Well, if I solve that equation, I get that x is minus 1. And comment on its significance, well, when the second derivative is 0, this means it is a point of inflection. And we know it isn't a stationary point because in the previous question when x is minus 1 that didn't make the first derivative 0. So it's a non-stationary point of inflection. This means the gradient is a local maximum here. So this is the steepest part of the gradient around this section of the curve. So whenever we get the second derivative equal to 0, this is the point of inflection which has the greatest gradient. Hopefully these few reminders will help you when you do your getting ready for pack on differentiation over the summer. Thank you and enjoy the rest of your holiday.